they're giving us all the concentrations at equilibrium. Nice. These are the easiest or the simplest types of problems because all you do is plug and play. All right, the expression for the equilibrium constant expression is the concentrations. That's what we're looking for, Kc. It's going to be the concentrations of the products, which here is carbon monoxide. This is balanced and there are no coefficients either, so piece of cake. Concentrations of the products, which is the carbon monoxide and water. All right, and you do have to make sure that these are all gases or aqueous solutions. All right, it wouldn't work for liquids or solids. All right, over the concentrations of the reactants, which is carbon dioxide and hydrogen. Let's put these numbers in. 5.552 goes right there. That's carbon dioxide. So let's do that. 0.552, and then 552 of the other reactant. 0.552, 0.448, 0.448. Well, you may be like, well, of course they're the same numbers because every 1 mole of carbon monoxide, you're going to get 1 mole of water. Well, not necessarily. I mean, that's assuming the initial concentrations were all the same and like you didn't start with any products and so on. But you know, things can get kind of tricky when your initial concentrations are like all over the place. All right, in any case, that's not the scenario here. It's just very, very straightforward. We're just going to plug these numbers in our calculator. 3 sig figs in all of these. So let's go 0.659. And we can write that in scientific notation as 6. I said 6, but I wrote 5. 6.59 times 10 to the, we move the decimal 1 to the right, so it's going to be -1. There's our answer.